Hello everyone. So today in this video we are going to solve a question of LeetCode. That is search in a binary search tree. This is 700 question on LeetCode and this comes under easy category. Alright, so let's start with the problem statement. You are given the root of a binary search tree BST and an integer value. Find the node in the BST that the node's value equals value and return the subtree rooted with that node. If such a node doesn't exist, it is written null. So basically we have given a binary search tree in this question and we have given a value and we need to find this value in this binary search tree. If this value exists in this binary search tree, then we need to return that node from here, otherwise we will be returning null. Alright, so there are two approaches to solve this question. The first approach is the iterative approach. So let me write here. First, let's talk about recursive approach. So recursive approach will take around big O of h time complexity and space complexity. So let me write time complexity of this recursive approach is big O of h because it will traverse through all the like one of the elements, like whether the left one or the right one. So the maximum time which it can take is, or we can say the maximum elements which it can go is either the left one or the right one, so that the minimum would be the height of the binary search tree, like or we can say the maximum number of nodes which it can traverse in the worst case is the height of the binary search tree. And the space complexity is also same because the recursive approach will store all the h elements. Alright, so the time and space complexity of recursive approach is because of h. Now we need to optimize this approach. So to optimize this approach, we can optimize space in some way. So let's talk about another approach. So the another approach is iterative approach. So iterative approach is, let's talk about this. The time complexity is big of h because again we are traversing through all the h elements, or we can say either the left one or right one in each level. And the space complexity is constant here because there is no recursive stack here. Alright, so the space complexity of iterative approach is because of 1. So we will be discussing iterative approach in this video. Alright, so let me take a pen here. Alright, yeah, so let's start with the root. So this is root. Alright, so we are just starting with the root. So first let's check if root is equal to null. If the root is null, we will be directly returning null from here. Otherwise, what we will do, we will check for this value in this binary search tree. So what we are doing is we will be running a while loop here to check for each node. So while root is not null, now let's check if this current root is equal to the value or not. So if root value is equal to the given value, if this is equal, then we will be running this root from here. So return root. Otherwise, else what we will check. Now what we need to find is whether to move this pointer here or this pointer here. So how we will decide this? So there is a property in binary search tree that the left one is less than the root is less than the right one. Alright, I hope you know this property. Let me write here once. The property is the value of left node is less than the value of root node is less than right one. This is the property of binary search tree. The same property we are using here to find where to move this pointer. So let's check here. Let's say in the first example we have value equal to 2. So value equal to 2. So 2 is less than 4. When 2 is less than 4, so what we can say, This is root is 4 and value given us is 2. So definitely this will belongs to this left one. So we will just move pointer to left side. So let's check else if root value is less than value. Okay, so what we will do, like in this case root value is greater than value. So let's take this one. If root value is greater than, that is 4 is greater than 2, then what we will do, we will just update root to root left. Otherwise we will just update root to root right. Alright, I hope you understood this. We are just checking this property of binary search tree. Left is less than root less than right. Now if the root value is present here, or we can say the given value is equal to any of the root value, then it will return that node from this while loop. If the value is not present in this binary search tree, then at the end we will just return null from here. Okay, so I hope this is fine. Let's just run it. Yeah, it's working fine. Let's submit it. Yeah, it's working fine. So the time complexity and space complexity of our approach is this one. Time complexity is because of h. H is basically the height of binary search tree, and space complexity is because of 1, because we are using constant space, or we are not using any space here. Alright, so yeah, so that's it for this video. I hope you understood the solution. If you still have a doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. Thank you.